Yeah,
Uh,
Abhishek.
Sir, are the borders compulsory? Because
Actually, if you in the market, the drawing sheets available having some border lines. Okay,
yes,
you
sir.
can have that such the border is sufficient. Okay, you need not draw any further borders, and sometimes title block is also drawn. They use the same title block. You need not draw any further title blocks. Okay.
Sir, I asked for A2 size, but they are giving without border. No, I mean A2 size is without border. Border one is a smaller size, sir.
Okay, no issue. But you better you take border one. Okay, because you can avoid some time. Okay,
Yes, sir. Okay.
you can save some time. Better you go by the charts with borders and title block.
Okay, sir. Thank you.
Don't buy blank ones. Okay,
Okay, sir.
but don't use some are posting in some in my. I am getting some mails from you that we are using A4 sheets. No, don't. I don't accept. Okay, you better purchase drawing sheets only. Maybe it is even short length, no issue. But a drawing sheet is having some thickness, more thickness, which is compatible for your compass, drafter, drawing board. Okay, so don't use A4 sheets. Yeah, I think. Any further doubts?
Sir, what all information we should fill, sir? The name and all.
Uh,
Actually.
the title block, whatever is there, you just write down. No, no issue. Okay.
Okay, sir.
Mainly put the date. Okay. Write conic sections. In the assignment problem, you can mention the it is a parabola. Assignment one, date. Your roll number, name. I think any section, college name you can write with capital letters. Okay. Draw by drawing 5 mm height lines. Okay. In between you can write with HB pencil. Maintain neatly. You have to submit those charts in the college. Okay.
Okay, sir.
Sir, now can we submit to you by through classroom, sir? Google
Yeah.
Classroom.
Yeah. Yeah. You can easily upload by taking a photograph, converting to JPG or something. Directly, it is automatically converted to JPG. I think. Okay. Directly, you can post JPG or in the form of PDF. Also, you can post. There is an option called upload. Upload your submission. Something like it will ask. Simply upload it. Okay. Nothing wrong. You try. Some of you, two students out of 60 already submitted. I have given grading also 100 out of 100 marks. Okay, like that. 100 is something like grade, but I will convert into 15 marks later. Okay,
Sir, where we should submit it?
Google Classroom. Log into your.
Sir, I have submitted, sir, but I drew in my notebook, sir, A4 size book, not in drawing sheet, sir.
Yeah, you again you draw on the drawing sheet, and again you take a photo, and again you upload it once again. Okay, no issue.
Okay, sir. Okay.
uh, Log into your Google Classroom. There is a student work, some streak, some options are there. You study all those things. It's not great software. You can easily understand the software. You can upload whatever assignments are given. Okay. So let us please stop your questioning and let us move on to the next topic. At the end of the class, I will give you 10 more minutes. You can ask further doubts. Yeah. So in this class, let us see new topic. Okay, again, it's a engineering curve, like elliptical curve and hyperbola curve. It is also an important engineering curve. Again, you need to remember the steps involved in it. Okay. Uh, and directly you can able to make the drawing. It's simply just memorizing the steps is very important. I think there is not much particular concept is involved in this particular topic. Maybe in the next further topics, you need to apply your concept. Okay, knowledge is more uh, there in the future topics, but these topics, conic sections, requires memorization of the steps, not more than that. Okay. Okay. Then today's class, I would like to share my screen. Cycloids. First, let me give you some basic. Uh, are you able to see the screen?
Yes, sir.
Yes,
Yes.
Yeah, these are
yes, sir.
very good. These are some special curves like cycloid, spiral, involute, helix. Luckily, you don't have all spiral, involute, helix in your syllabus. Only cycloid. In cycloid, we draw cycloid, epicycloid, hypocycloid. Okay, so our focus is on only cycloid. The mathematical formula x is equal to a times t minus sin nt, y is equal to a times 1 minus cos t. Okay, anyway, don't you need not remember these formulas, okay, because we are not interested in mathematical formulas. We are interested to draw the curve. Now, are you able to see the red curve like this?
Yes, sir.
And yeah, so it is continuous process. It is taking curve like this. How this curve is generated and how to generate the required points. If you don't get required points, you may not draw this curve with your free hand, right? To draw this particular curve, you require a number of points. Okay, so our task is we need to generate so many number of points so that we can easily draw the curve. Now further, uh, but remember, even though you don't have syllabus in your syllabus, spiral, involute, helix, okay, but better to have some knowledge on spiral. It is something like it is something like when the spring, you can have this particular diagram, right? If you see this diagram, okay, it is in the form of spiral. Suppose if you take a spring, okay, if you see its front view, okay, or top view, it will be like this. So it is something like spiral, and involutes will be like this. Similarly, helix will be like this. Helix. Okay. Anyway, we are first we will focus only cycloids. If you are interested, you can go ahead with this spiral, involute, and helix, but you don't have in your syllabus. Okay. Only cycloids syllabus. Remember. Okay. Don't practice everything. Okay. Listen carefully. To have a broader perspective on the special curves, I am telling all the spiral, involute, helix. Okay. So yeah, these are also there, but in your syllabus only cycloid is there. So for that reason, I am telling all these things. So you need to have a small idea, like why, how spiral looks like. The springs are the application of spiral. Okay, like that involute in the gear. Mechanical gears are there in automobile engineering, right? If you take any two-wheeler, even in your watch, there are small gears, plastic gears, or steel, aluminum gears. There you will find the teeth of the gear in the form of involute. Okay, but don't worry. Uh, there are some other applications also for spiral, involute, and helix. Even our cycloid, which is in our syllabus, also having applications in mechanical gears, and some other applications are also there. I will show you later, and remember all those things. Okay. Now here you see there is a gear. It is a mechanical gear. So if you zoom this gear, there you will find a special cutting at the teeth. Okay, in the form of cycloidal curve. Okay. Yeah. Now, just I am zoomed it. Okay, the profile of the gear. You see here, that these are the teeth of the gear. So many teeth are there for a particular gear. So if you see the profile cutting of that gear, okay, you will find. Now I am showing you here orange type of thing, that is epicycloid, and like that you can find. I will show you all cycloid gears are similar. Three types of gears are there. And there is one more application for this cycloid, isochronous pendulum. You might have heard about it in your engineering physics, I think. So the shape, the path it is taking place while it is oscillating, okay, it is in the form of a cycloidal curve. It's a special curve. And now our interest is to construct it, how to construct it on a drawing sheet. Okay, let us see. Uh, so I will tell you step-by-step procedure. Before that, what is the cycloidal curve means? Suppose if you take a cycle wheel, suppose you imagine this cycle wheel. This is the ground. Okay, this is the horizontal ground. Suppose there is a contact point which is common to cycle wheel and onto the horizontal ground. There is a common point P here. Okay. For example, if the cycle wheel is rotating, okay, horizontally without any slip, okay, it is just rotating. Then, suppose if you take a pointer on the cycle wheel, this pointer is also taking its different positions while it is rotating, okay, from this point to this point, or if it is taking one complete revolution, okay, complete one complete revolution from here to here, okay. So if you mark a point at the bottom of the circle initially, that point while it is traveling from this place to this place, okay, for one complete revolution, that point will take different positions along the path. Okay, that path, that point, taking that path, we call it as cycloidal curve. Okay, now, yeah, I would like to share one more screen to explain everything. I think I will show you one more figure to draw how to draw the cycloid. Okay. Yeah, 1 minute. Yeah. So like ellipse, are you able to see the screen? Any problem?
No, sir, no.
Yeah. Like ellipse, parabola, hyperbola, a small data will be given in the problem. A cycle of 50 mm diameter rolls along a straight line without slipping. Draw the curve traced out by point P on the circumference for one complete revolution of the circle. Name the curve. Draw the tangent to the curve at a point on it 40 mm from the line. So like ellipse and parabola, here also we need to draw normal and tangent. Okay. Simple data required. Okay. To draw this particular cycloid. A circle 50 mm diameter rolls on a straight line. That is sufficient. You can go with drawing this particular cycloidal curve. No other data required. Okay, the cycle wheel diameter is required. Okay, I asking for one complete revolution. Now tell me, if you take any point on the circumference of a circle, if it is traveling for one complete revolution, what is the path it is traveling? Total distance it is traveling?
Sir,
Yeah, is my question not clear?
the screen is not visible, sir.
Screen is not visible?
Yes, sir.
Yes, sir. No,
No,
sir.
sir.
No, 1 minute. Again, I would like to share it again. Is my screen visible to you or not?
Visible, sir.
Yes, sir.
Yeah, my question is, we need only simple data like the diameter of circle, okay, and for one complete revolution of the circle. The data is sufficient. We can draw this particular cycloidal curve, okay. This is called rolling circle, okay, or something like a cycle wheel. It is rolling circle. The diameter of the circle is 50 mm. The data is sufficient. Now you can draw. You can remember the step by step what I am going to teach you. Remember and just follow the steps. If you are ready with the drawing sheet, draft or everything, you can follow step by step procedure. Just I am explaining. You can draw on your drawing sheets immediately along with me parallelly so that you can save some time. You can uh, uh, you can use that time for other subjects. Okay, so that's why I'm recommending you to draw parallelly with me so that you don't have any question later. So in the last class you are asking right side of the para ellipse we don't understand, sir, like that you are asking, right? So while I am teaching, if you draw along with me, even such questions also may not arise. Okay. So anyway, if you are ready, please make it up, or else you practice at the end of the class. Okay. The first important step is you read the problem carefully initially. Okay. That is very important. And note down some important uh, some important theory aspects or data given in the problem. Okay, circle rules and a straight line for one complete revolution. This is important key data given in the problem. Neglect about tangent and normal do later. So diameter capital D 50 m. So for one complete revolution, what is the length it is taking place traveling on the horizontal ground? Do you have any idea?
Circumference.
Yeah, very good. Circumference means what is the formula?
2 pi r.
Yeah, yeah, you can write pi d or 2 pi r. So you know pi means 22 by 7 into d. Calculate 157.14 millimeters. Now you calculate this simple calculation. Then you start our problem like this. Now what you have to do is you take a circle. What is the diameter of the circle?
50.
50. What is the radius then with compass?
25.
Yeah, with compass takes 25 millimeter only, 2.5 centimeter or 25 millimeter. Draw one circle. Draw one circle. Okay, and at the bottom of the circle mark point P, and from P you draw one horizontal line. Okay, PQ, which is of length pi d, which is of length pi d. Now you can understand why we have drawn this pi d length, because the point P initially here, after traveling one complete revolution, after if the circle or cycle wheel rolls for one complete revolution, initially the circle is here, right? After some time it is rolling and all, so it goes to here, then it is taking a maximum distance of pi d. Okay, now divide the circle into equal parts, even number of equal parts. How many parts I have divided here? Can you tell me how many parts I have divided?
8 parts.
8 parts.
8 parts.
8 parts, right? So how to divide that with your instruments? You have so many instruments, right? Which instrument you have to use to divide the circle into 8 parts? Any idea?
360 degrees protector.
Yes, sir. Protractor.
Protractor, yes. 8 parts means what is the angle of the protractor you need to take?
45
45
degrees
degrees.
each.
Very good, very good. Very good. You can take even 12 parts by taking 30 degrees, so that you will have so many points so that you can easily join the curve. Okay, so don't take less than 8 parts, minimum 8 parts you take, and even you can take 12 parts. Now you see the rolling direction. Is rolling clockwise or anti-clockwise?
Clockwise.
Very good. So starting point is P at the bottom, which is touching the ground. This pi d length I am drawing horizontally, right? That is, treat this as ground, horizontal ground. Now the numbering system, you need to put the numbers to the parts. You have divided 8 parts, right? So from P in the anti-clockwise direction, give the numbers 1, 2, 3, 4, 5, 6, 7, like this. Okay. That means this is the first part, second, third, fourth, 5, 6, 7, 8 parts are there. You need not mention 8 because already P is there. Don't write any 8 here. Not required. Okay. So remember, the rolling direction is clockwise. Take in the anti-clockwise number system. 1, 2, 3, 4, like this. Can you do up to this? Any difficulty here?
No difficulty, sir.
Yeah. The next step is find mark the center somewhere here. Okay. You call the center point as some C. Okay. Then how many parts we have done circle? 8 parts, right?
8 parts.
Similarly, the pi d length also divide into 8 equal parts. Okay. 8 equal parts. How to divide length pi d 8 equal parts?
Line division method.
Yeah, very good. Line division method, you know, we need to draw 8 arcs on the angular line we have taken. Okay. Can you make it like this? 8 arcs. 1, 2, 3, 4, 5, 6, 7, 8. Okay. What is the angle of this line?
Any angle.
Any angle.
Between
Very
0
Less
to
than
90.
90 degrees.
Yeah, 0 to 90, any angle according to the space available on the drawing sheet. If you take more angle, you know, it will take more space on the drawing sheet. So you better you take a smaller angle and mark 8 arcs. Last arc we need to join to the other end of the line which we are going to divide. Okay. So this point join to the other end of the line like this. This is very important line. Okay. And here I am showing you one more circle that you need not draw, not required. Okay. If you are interested, you can draw, nothing wrong, but it is not required. So after that, to divide 8 parts, I have to adjust my main drafter parallel to this line and move the drafter parallel to this line from different arcs. Okay, like this. Can you do this, right? So automatically this horizontal ground is divided into 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this 157.14 roughly you can, with mini drafter, you can take it as 157. Okay, forget about this 1.14. It's very negligible, right? So you automatically divided 8 parts without any calculator, not required. Okay, directly you can use this line division method. Automatically this length id will be divided into 8 parts. Okay, the next important step is numbering system. Take p, or you can take pq, whatever you wish. Then put the numbers 1 2 3 4 5 6 7. Okay, and the dimension line you can put like this, away from the drawing. id equal to 157.14. Okay, like this. Then next important step, passing through 1 and 7, you will draw one horizontal line. Passing through 2 and 6, draw one more horizontal line. Passing through 3 and 5, draw one more horizontal line. Passing through 4, you draw one more horizontal line. How many lines are there now? Horizontal lines? Apart, apart from the ground line, 1, 2, 3,
Four.
4. 4 lines you have to draw. Okay, so the first line says line 1, the line common for line 1 and 7. The second line is common for number 2 and 6, right? The third line is common for 3 and 5. Line 4 is common for 4. So these are the 4 horizontal lines we need to draw. So next step is, yeah, here you see, from the ground we got 1 2 3 4 5 6 7, right? Draw vertical lines up to the center line, up to the center line. The red point is there, right? That is the center of the circle. There already you have a line, okay, passing through 2 and 6, that is the center line. Okay, up to that you extend, or what, you draw perpendiculars from the ground. Okay, like this, like this. Okay, thereafter you number starting from C naught. The center of the circle is C naught, and the first perpendicular from the ground is 1 to C1. Okay, and second perpendicular 2 to C2, and third perpendicular 3 to C3. Like that you continue up to C8. Actually C8 is not required. Okay, up to C7 you can do it. Okay, then almost like ellipse, parabola, hyperbola, we have almost done the procedure or steps required to construct a cycloid. The last important step is, take your compass, set the radius 25. The radius is constant. Don't change the compass radius, okay, till you complete all the arcs. Okay, take your compass, radius 25. The center of the compass will be changing from C1, C2, C3, C4, like that. The center of the compass is changing, but the radius of the compass is 25 only till the you are cutting all the arcs. So take your compass, set the radius 25, okay, which is the rolling circle diameter or radius, and fix the compass or set the compass such that it center at C1. This is the first center of your compass. Okay, then cut the line which is passing through 1 and 7. This is the first line we discussed, line 1. So first arc, the center of the first arc is C1. and cut the first line passing through 1 and 7, somewhere here, somewhere here. And you change the compass from center 1 to center 2, cut the second line, the line common for 2 and 6, somewhere here. Okay. Similarly, you can proceed with the same procedure. You will have so many arcs. Just watch the video, you can easily understand. Sometimes it is very difficult to so take your compass, set the radius 25, and you see here red point. Okay, it's a starting point P, red point. So I have generated one single point here, 1 point. How I got this point? Once again I am telling, taking the radius 25, center is the first center C1. Okay, we have marked already C1, C2, C3, C4, C5. Okay, after drawing the perpendiculars up to the center line. Okay, so C1 as center, cut the first line. This is the first line I told you. This is the first horizontal line passing through 1 and 7. So with your compass, center C1, cut the first line somewhere here. Okay, and you proceed with the same procedure. Go to center C2, and here this is your compass. Now center of the compass here C2, and radius is fixed, right, 25 only. Cut the second line passing through 2 and 6. Somewhere I got the arc here. To you, can I move forward? Anyone, please respond.
You can move, sir.
Yes, sir.
Yeah. Now go to center C3. Okay. Cut the third line common to 3 and 5. Next, go to C4 center and cut the fourth line. Fourth line is common for only fourth point. Okay. And you will get one more. Now you see, you may have a doubt here. If you go to C5, center C5, where I have to cut left hand side or right hand side? Because we are moving, the curve will be looking like this, right? Symmetric curve. So after finishing the center point, center dot we have generated, the next thing is points you have to cut right hand side. Okay, right hand side you have to cut the arcs. C5 is the center, and where is the fifth line? Line common to 3 and 5 only. The same line you have to take, because center C5, fifth line means again line common for 3 and 5. So cut the fifth line. Right hand side you have to cut like this. Don't cut left hand side, because we are getting a symmetric curve. That you must know. That you must know. Now go to the C6 point. Again, center C6. Which line I have to cut? Can you please tell me whether you are following or not? From center
Center
C6.
line.
The line common for which points?
2 and 6.
2 and 6.
Very good, 2 and 6. You will get one more point. Lastly, C7. Lastly, C7 is the center, and cut the line passing through 1 and 7. So I got the required points. You need not consider the C8. I told you don't write any 8 here. Okay. You need not write 8. Take C8. C7 is sufficient. Then, lastly, the ID initial point is P. The end point is also P. You can note down. And so I got how many points? Starting with P1, P 1 point, 2, 3, 4, 5, 6, 7, 8, 9. So if you neglect the base ground points, you will have 1, 2, 3, 4, 5, 6, 7. Actually speaking, you have generated only 7 points. P and P, starting and ending points, are the horizontal ground points. Okay, where the point is started, okay, we have taken, and where the point ends. per one complete revolution, this is the length traveled by that point horizontally. Okay, by the length it takes horizontal path. So this is the procedure to generate all the required points. Thereafter, it's a simple procedure. You can take your HB pencil, all other lines till now, including the circle, including the perpendiculars, all horizontal lines, even the line division method, all you have to use 2H pencil, light pencil. Okay, then coming to the HB pencil, take your HB pencil, use freehand, draw smooth curve passing through these points. You will get a smooth curve. I call it as cycloidal curve. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now, one more important thing is how to draw the normal and tangent if you are given a point on the curve somewhere. Okay. So, select any point. If it is given in the problem itself, you follow that distance exactly. Okay. So, in the problem, it is given some height, right? Some 40 mm. From the ground, you take 40 mm horizontal line. It is meeting the curve somewhere here. Okay, you call that point as some Q. Okay, just listen. Thereafter, I will. And from that point Q, take again your compass, radius 25. Cut the center line passing through 2 and 6. Okay, somewhere here. Okay. After that, you draw vertical line onto the ground. It is very important because these steps you can apply for even epicycloid, hypocycloid. There are two more curves, special curves in this particular topic. Okay, we need to draw again the same procedure you can adopt. So remember the steps. While drawing normal and tangent also, you can adopt the same procedure. So from the given point on the curve, this cycle.
Sir, can you please show
Yeah.
the can you please show the method to draw normal and tangent again?
Yeah,
Sorry.
yeah. 1 minute. See, 1 minute. At what height you are asked to draw the normal and tangent? It is given some 40 mm, right? So you draw 140 mm horizontal line from the base, parallel to the base, parallel to the ground. You draw one horizontal line. So you call that point as some Q. Okay, and from that point, take 25 mm radius. 25 mm radius. Draw one arc on the center line. Center line passing through 2 and 6. This arc you are getting, okay, with compass. From that point, you draw vertical line onto the ground. So this is the point. Now take that point as some M. Okay, join M and Q. That is the required. Now tell me, it is normal or tangent?
Normal.
Normal, sir.
Normal, because it is passing inside the. It is passing inside the curve. So normal. How to draw the tangent? Now do you tell me?
Draw a line perpendicular to the normal and it will be tangent.
Correct. Simply, normal and tangent are mutually perpendicular to each other. Already I got the MQ line, normal line, protractor or mini drafter. Mini drafter 90-degree scale is there, right? Simply you match one of the mini drafter scale to this MQ. Draw one more perpendicular line to that. That is going to be your tangent. Okay. So like this, you need to draw tangent. You see, this is the tangent. just it is drawn outside the curve, touching the curve, okay, tangentially, I can say. So this is the way you need to make up the cycloidal curve. So
Where is the second set required?
yeah, it is looking like it is better you draw a circle, but don't divide into 8 equal parts because it is confusing. Okay, you want to draw, simply draw a, because it is the end point of the particular wheel. It is traveling from here to here. Okay, you draw, it is looking nice only, right? Nothing wrong. Even though if you don't draw, nothing wrong. So here I have shown you here 40 height. Okay, you draw one horizontal line. That is the required point from at which we need to draw the normal and tangent. Okay, so for that reason I have drawn one 40 height line here. With your drafter, just mark a point at 40 and draw horizontal line with the help of mini drafter parallel to the ground PP. Ground PP. Okay, now if you see the overall picture, actually what is happening is while traveling this, while rolling the cycle wheel, the center C0 is changing its positions from C0, C1, C2, C3. Okay, that means it is traveling horizontally. So center line is not changing. Center line is not changing. Okay, that is the concept behind this drawing normal and tangent. That's why we are cutting the center line while making the normal and tangent. Okay, you would understand later. Don't worry. Any confusion in the procedure, you can raise it 2 or 3 questions. Then we will move further. Okay, we will discuss further. Any other specific questions? Or else can I repeat entire procedure?
Yes. Yes, sir.
Repeat, sir.
Yeah.
Yes, sir.
Yeah. Yeah, is my screen visible to you? Again, any problem?
Yes, sir. Visible.
Yes, sir, it's visible.
Okay. Now, this is the problem you are given. Here, the data is very simple data. Simply, they will give you only diameter. Draw the cycloidal curve for one revolution. That means pi d length only. So take a rolling circle, 25 radius. The diameter is, since diameter is 50, right? Draw the circle. First, you divide into 4 equal parts. Then you can use bisector method, or you can use protractor to divide this into 8 equal parts. Then give the numbering system opposite to the direction of rolling. Okay, take 1, 2, 3, 4 like this on the opposite direction to the rolling direction. That is important. And make it as 1, 2, 3, 4, 5, 6, 7. Starting point P, end point also P. ID length is 157. If it is 157.8, take 158, but it is 157.1 only. So take only 157. Divide this pi d also 8 equal parts like this. Okay, using line division method explained earlier, right? And you can draw one more circle at the end. Not required, but if you want to draw, you can draw. And draw 4 horizontal lines passing through 1, 7, because 2 and 6 will lie on the same line, 3 and 5. Similarly, you draw 4 horizontal lines. Use mini drafter while drawing these horizontal lines. Okay, whenever you draw with your mini drafter, first you set the mini drafter parallel to matching to this PP ground line. While moving your drafter from here to here, so see that initially you have to set the mini drafter matching to this PP, type the mini drafter now. Okay, Then gently move your drafter from bottom to top. Start passing through 1, 7, 2, 6, 3, 5, and 4. And while moving the drafter, only you hold mini drafter knob. Okay, don't keep your hands on the scale. Okay, only you hold the mini drafter knob. After tightening the drafter knob matching to this PP, then hold the mini drafter knob and move the drafter, okay, from bottom to top to draw the horizontal lines passing through 1, 2, 3, 4. That is important. Usage of instruments is very important. Use them gently. Okay, even if you use H pencil, if you handle it, okay, if you press it hard, it acts as a HB pencil. Okay, like that you must take care. Use pencils according to the purpose. Okay, HB you must use like HB, dark. Okay, don't press more than required, and don't tight the knob after knob. Okay, more than required. Like that you have to use the instruments properly. Sharpen the pencils very. Uh, the pencil sharpness is also very important. Okay, so while drawing vertical lines also, you see drafter scale you have to match to PP. Other scale is there. The drafter scale is 90 degrees, right? So other scale you have to use for drawing these vertical lines. Okay, just move the drafter from left. Draw vertical lines up to the center line. Name it as C0 center, first center C1, C2, C3, C4, C5 on the center line, only up to the center line. Extend all the verticals. Thereafter, our procedure is almost completed, right? Take your compass, set the first radius, or the radius is fixed, right? First center C1, cut the first line common to 1 and 7 somewhere here. Okay. And this is the first arc we are getting from center C1. Radius is always constant, it's 25 only. Don't change the radius because through the rolling, the circle diameter is not changing. Okay, so don't change the radius of the compass, but change the centers C1 to C2, C2 like that. In that way, you will have so many points like this. Okay, simply join all those points with a smooth curve, freehand only. Don't use any French curves. Okay, you practice. First time may not come exactly, and see that it is symmetric. Up to this, how you are drawing, similarly try to draw in the same fashion. Okay, with the right hand side also. Okay, then you will find a smooth curve like this. And for finding the normal and tangent, what you have to do? Take any point at a given distance, 40 mm height, draw one horizontal line. You call that point as Q. If nothing is given about the height 40 mm, you can choose randomly anywhere on the curve. Apply the same procedure, you can get the normal and tangent at that point. Okay? For curve, at any point on the curve, you can get one normal and tangent. Okay? So after selecting that point Q, 25 mm radius with compass, cut the center line. Cut the center line. Somewhere here with the radius 25, I got this arc. Okay. After cutting the center line, you got one point here. Drop down one more line onto the ground. Like this. Over. Now you will get one more point here on the ground. Join that point to Q. Okay, starting where you have selected the point on the curve. So you call this point as M, and this point is already Q. This is the normal. Tangent by with help of protractor or mini drafter scale, you can draw the normal at point Q. At point Q, you need to draw one 90 degrees line to this particular normal. That is the required tangent. So I hope can you be able to make up this sketch, this drawing in the next class? Can you show me?
Yes,
Sir,
sir.
yesterday you have given 3 diagrams, sir. That one we should submit to your mail, sir.
Okay, I'm asking, can you able to make up this cycloid?
Yes, sir,
Yes,
but
sir.
how to show you?
Yes, sir.
Yeah. Okay. First, tomorrow, you submit all the previous topic, ellipse, cycloid, ellipse, parabola, and hyperbola, and I will give you some time for submitting cycloidal curves. Okay. I will tell you. Okay. But
Yes, sir.
up to that, wait. I will give you some deadline. Okay. Meanwhile, you follow the lectures. So I think, do you have any question here on the cycloid?
No, sir.
No. Okay. Right. So let me share. What is next is epicycloid. And what's the time now? So yeah, we are having 7 more minutes. Just I will give you some outline of epicycloid. Then we will discuss or we will draw the next class. Okay. Please
Sir,
wait
one
there.
doubt, sir.
Yeah, in this cycloid.
Sir, no, sir. About the drawing sheet, can we write with pen, sir? Everything on, I mean, titles,
Yeah. No,
title names,
no.
and
Yeah, never use pen. Okay, always use HB pencil while writing title and all. Okay, and
okay,
inside the drawing area, wherever you require to use HB pencil, there only you can use HB pencil. Otherwise, use 2H pencil only. Okay,
okay, sir.
never use pen. Okay, I will give you an option like while writing your name or roll number, anyone you can use pen. Otherwise, don't use anywhere pen. Okay.
Okay, sir.
What only roll number or name you can use pen, otherwise don't use. Then coming to the I will give you small introduction of epicycloid. Okay, are you able to see the screen?
No, sir.
No, sir.
No. Okay, wait, again I have to share. Yeah, I think you are able to see that.
Yes, sir.
Yeah.
Yes, sir.
See, it is again almost similar to the cycloidal curve. Okay, but the data is more given. Diameter 50, circumference. It is rolling on a circumference of another circle of 175 mm diameter and outside it. Okay, just I will show you this class. I don't want to discuss in detail. As given rolling circle like earlier cycloidal curve, and here one more directing circle is also there, on which rolling circle is rolling outside that particular directing circle. So you just I will show you here actually this PP, this is the ground. Earlier the ground is horizontal, right? Now the ground is not horizontal. We are calling it as directing circle, on which actual our cycle wheel is rolling now. Okay, that means there is a curved path. There is no horizontal ground here. There is a circular path is there. Okay, on the above the circular path. Okay, outside that path it is rolling now. That is the difference. The procedure, everything is same. Earlier we have drawn horizontal lines from 1, 7, 2, 6, 3, 5, 4, right? Now we will draw circular arcs passing through 1, 7, 2, 6, 3, 5, 4. Okay? So because it is having some directing circular path, we are supposed to calculate some included angle. Included angle we will calculate by using simple formula. Apart from that, there is no procedural differences. You can apply the same procedure, you can use the same steps followed for cycloidal curve. You will get automatically the epicycloidal curve. So briefly, I am showing you how it looks like. Again, we are generating centers, okay? Everything is same. We are getting so many points to be joined together to form epicycloid. Now I got so many points, okay? Thereafter, using freehand, I will join starting from P to ending with P. So now I will ask you, what is the difference between this curve and earlier curve? Is there any difference? It is looking like that only, right? Previously we have drawn cycloid. Do you find any difference? Yeah, any questions or any response? I'm asking some question, right? Do you find any difference in the curve?
Sir, previously PP dash was horizontal.
Okay, that is different. Procedural difference is different. I am asking the curve. You look at the red curve, red curve.
No, sir.
Is there any difference compared to the previous cycloidal curve?
Near the ends, it is bending inward, sir.
Yeah, little bit difference is there. If you see, okay, in depth, nearby starting and ending, it is little bit bent towards inside, okay? Anyway, that much in detail differences we need not require, but almost it is having cycloid only, okay? And so we would like to draw in the next class this particular epicycloid. And there is one more cycloid, that is hypocycloid, that I will give you as assignment. Okay, in the next class, what we will do is we will draw cycloid along with this epicycloid. You need to draw on your own hypocycloid. So that is the assignment. So try to listen this particular epicycloid carefully in the next class so that you can make up that assignment too. Okay. So any other questions regarding how to upload assignments, how to see the Google Classroom? Any problem with Google Classroom? Are you having any issues to log in Google Classroom? You can discuss. We are having one more minute. So I'm taking one attendance. Only 53. What happened to remaining students? Okay, we will monitor attendance also.
Sir?
Yeah, please tell me.
Sir, we should send the assignment to your mail, sir.
Not mail. Whenever you enter Newton Classroom, right, you will find Google Classroom also. There you will find whatever the assignments I have uploaded. Okay. Particular option called submit your assignment. Okay, submit your submission, something like that. You will get. You can directly. First of all, you have to take a photo of your assignment. Okay, on your desktop. Okay, just submit that. Browse that. Okay, you will submit that assignment.
Sir,
Already,
along with assignment, we should attach ellipse and hyperbola also, sir.
Yeah, correct. Attach separately. Okay, do it
Okay.
separately. Okay, keep the drawing sheets with you till offline submission before mid exams. Okay.
Okay, sir.
So once again,